Your LLM endpoint works in testing, then a client wants 10,000 concurrent requests. Do you spin up 10,000 threads? Buy a 100-core server. Neither, and why is beautiful. When your server calls an LLM, what is it actually doing? Almost nothing. It sends the request in microseconds, then waits seconds for tokens, then receives bytes in milliseconds. That middle wait is the whole request. No computation, just waiting on a remote host. That's I/O bound. The bottleneck is the network, not the CPU. So async helps enormously while you wait and nothing while you compute. The old way gives each request its own operating system thread. When it waits on the LLM, the thread blocks parked, burning memory. Each thread needs a stack of 1 to 8 megabytes. So 10,000 waits means tens of gigabytes before any logic. Sync servers cap at a few hundred, then fall over. Now a competent waiter takes table 1's order, hands it off, moves to table 2, returns when 1 is up. One waiter, 20 tables. That's async. The machinery is an event loop, one thread constantly asking who's ready to run. Requests become coroutines, functions that pause at a point you mark a wait. When a coroutine awaits the call, it yields control. The loop runs another, then another. When the first request's bytes arrive, the loop resumes it right where it paused. And a paused coroutine is almost free, a few kilobytes of heap. 10,000 in-flight awaits cost tens of megabytes, not gigabytes of thread stacks. The ceiling is now how many connections your provider allows, far more generous. Don't blur two words. Concurrency interleaves many tasks. One waiter, 20 tables. Parallelism runs many at once on many cores. 4 cooks, 4 dishes. For waiting-heavy LLM work, concurrency is enough. But here's the trap. Move heavy CPU work into an async function, and if it never awaits, it freezes the entire loop. No other request gets served. CPU work must be offloaded to a process pool. Async definite alone is not a speed up. The production shape is 4 things. 1 shared async client. So connection pooling kicks in, never one per request. An async endpoint, so the loop never blocks. And a wait on the call, yielding while you wait. And the piece that makes it a service, a semaphore. It is a counter letting at most n coroutines through the backpressure valve. Without it, a spike piles up thousands of awaits hammering the rate limit, and you cascade into 429s and out-of-memory kills. One more move. When a request needs several calls, gather them. Fire the summarizer and classifier together, and total latency is the max of the two, not the sum. Often a 40 to 60% saving, free. So the shape of it, LLM calls are I/O bound, you wait far more than you compute, sync spends gigabytes to stand still. Async waits for almost nothing on one thread. One competent waiter, the whole floor. That's just refusing to pay for standing still.